So the last subject before the dinner agenda item is talking a little bit about Greenfield. What does this mean? Where are we in this discussion? And so far we are safe?
Yes, very safe. It is very user-friendly, this tool, to go for presentation tool.
Oh, it's wonderfully user-friendly.
Because it would have been a disaster to put just there a laptop which everybody could operate and, you know.
It is powerful since it has all the microphones. It's not so easy to have only a laptop.
But that has nothing to do with it.
But switching from
Okay, this looks like success. Thank you. Do we that work? I think we can. We also said should. Yeah. Okay. No idea why this gets disassembled. Okay, so we have started to discuss in our working group about a Greenfield simulation framework. We have also thought a little bit about a definition of it. What we mean by that is, so we would like to call it Greenfield Event Processing Software. The community-wide project on event processing software, freeing us from the legacy of existing options by leveraging everyone's experience. The project will define requirements and build up the, I should read, event processing software on these requirements. Input by the wider scientific and software computing communities is encouraged. So what we would like to do is we would like to think about what is really required for software and computing for the EIC, in particular in the sense of processing events, analyzing events. When we understand and have written down the requirements, we would like to study existing implementations and then consult with the wider scientific community and also with software developers on these possible implementations. When we know what we want to do and think we have a good idea about what is available and what is done, we would like to agree on the design and then eventually implement that. Where are we with the requirements? So we just had a discussion where we went through the chain and just started writing down where we are. Originally, I have to say, for this meeting, we thought that we already have shared Google document where this is available. Unfortunately, I did not achieve that, but I updated with followed in all of our comments, our discussion on our slides. So part of that we already would like to write this up or now present. So we had these future trends in nuclear physics computing workshop, and one something which was a theme here was all scientists on all levels, wherever they are worldwide, should be enabled to actively participate in the data analysis. To achieve this goal, we must develop analysis toolkits which use modern and advanced technologies while hiding at the same time that complexity. So resolving this tension means putting a priority on the user experience and functionality, and that brings us to a user-centered design. And it's not only about analysis, it's also about data. So in the ideal case, the data needs to be open access, readily available, and needs to be in self-describing formats. And we would like to have the data trackable and linked to publications.
Can I ask something?
Please.
If you say data open access, what do you mean? That somebody off the street can analyze it?
This is, yes. I understand the sociological problem of that, but my answer to that is yes.
That said, I have no psychological problem with this.
Sociological.
But there is a significant issue in a different sense, which if I have two detectors which measure both the same thing and things are openly accessible, I lose scientific independence. Because people can then see everything from everybody, and that means if one does a bug and this is the result, the other people actually follow exactly the same direction, and this result which comes out is not independent anymore, it is actually dependent.
There are discussions on these open access also going on at CERN, which concern the fact that funding agencies are investing in putting up detectors, collecting data, and so on, and the fact that somebody comes and do the analysis and eventually publish is not so.
Yeah, but the D0 CDF example was CDF published, that's the cross-section for, I think it was D0 published, that's the cross-section for hadrons is higher than for jets, and then CDF could do the analysis and say, no, it's not right. And if you do this open access, then you lose all of this.
So these few bullet points which we have here are a whole presentation in itself. So
yeah, I know.
There's a lot of complexity in there.
This open access.
Can I ask just for clarification on this same point? Do you mean at the level of raw data, or do you mean at the level of analyzed data?
I just wanted to mention that I think it's for our field impossible to make the raw data available, because if you're not part of the experiment and if you never have done shifts or something, you absolutely have no clue what you would like to do with these raw data. But other data, process data, for instance, at an event level basis where you, let's talk about EIC, you already know what your X and Q square are, how your tracks looks like. I mean this kind of data. You can turn it a little bit around on the other example. I mean, a scientific principle is that results need to be reproducible. In our field, this is absolutely not the case, because we don't make you have no chance to, let's say, repeat an analysis of another experiment, because you have no access to the data. So you cannot just make the analysis yourself and see what you get out there. And
okay, I would like to veto this a little bit, because, and I think it's also true, we put the code, the analysis code, and so on, which will lead to a publication with the analysis node and things like this, archived on Git or some archive, CVS, whatever, SVN, any one of this. It's all frozen. We have somebody else, independent, who has not done the analysis, reproducing the analysis, showing that all of this can be reproduced, and then it gets published. It's true that Marcus couldn't come and do this. If you become a member of the collaboration, you could check it out and could do this.
But this is already great, because you already make your analysis code available.
Absolutely.
Think about our Hermes publications, where we are both on the and a lot of experiments done.
We are much further along than this. So
and along this discussion, what you mentioned, this is just something which I think is important, and it's important that when we design some software, that we have this in from the beginning, that you more or less can always automatically say, okay, this is my analysis macro, or this is my analysis notebook, and I know exactly what data has been used, and I can, for instance, point someone with a link this to an ID, and somebody can look this up and knows exactly what is done.
I think my understanding is that this is done within the collaboration, so it's there.
Yeah.
So this code is within, so it's not open I don't know when you say like
Yeah.
open.
And I think.
So with other
No, but,
collaborators, yes. But
there are some ideas of data preservation and the fact that the analysis can be repeated in the future.
That comes in addition. How can I use that in 20 years?
so that is when
That
you
is-
wrap up the
That
experiment.
is another, yes.
Yeah, but this is what I meant with sociological aspects. What you now exactly say is our thinking, but and the thinking is coming from that we say that the data is owned by the experiment and we are very careful in opening up this data. In some cases, let me again give Hermes as an example. There's some real hesitation in, for instance, opening up the data to the public to for instance.
For example, at Zeus, what we did is like common entables, so the data are preserved at an event base after the reconstruction, of course, on tracks and everything. Still, you need to contact the collaboration, but it's very easy to join, and I think H1 is the same. So probably something like this in the future, when you wrap up the experiment several years afterwards, if somebody wants to use your data collected 40 years ago and to analyze, I think it's easier.
Yeah, this is what I meant by, and again, a lot of these complexities or all this level of discussion are not presented in this bullet point, but this is what I exactly meant by sociological point of view. The collaboration can still say, okay, I embargo that data and give it out at a certain moment, but you still could have you could still have at least internally all these possibilities.
The worst end up with cases that you collect the data in a collaboration, somebody else, completely stranger, comes and publish stuff from out of an experiment that's founded by you, that you worked. And
that is not in the mind of
also not with the full knowledge of what you did. So yeah, that's on the concern of
I guess.
This is wait, Tom, please. This is the concern. The other thing is that if we make the data available, it already gives others a chance to actually really learn something about the data and do something with the data. So making it really accessible to theoreticians at an early stage.
I don't want theorists to analyze the data. Really? 9.
Yeah, okay, and we are, and these another aspect which I put in the category sociological aspects.
Yes.
Tom, I interrupted you. Sorry.
I guess I was just going to say that it's a very interesting issue, and I would be surprised at the end of the day that the collaborations will accept the decision of the software working group on this point.
Yes.
Again, another point for the sociological aspects of this.
We'll all be members of collaborations, and I think we can bring it up there.
I can actually just say that all those concerns arise from what I would say licensing issue or something like this. So if we can look at this from the perspective of like all fields and industry, maybe and other things. So if you release something, that's the question, what is the license for you? I mean, I'm taking license to the quotes, right? So, and I believe that if we regulate this license, it's okay to push data earlier.
In any case, data will not belong to the collaboration.
It belongs to taxpayers.
It will belong to the laboratory, it will belong to the funding agencies. So let's say we own and use it, of course, but the decision on the opening to the outside, I think it can be taken also above the collaboration and pushing for that.
Yeah.
As I was saying, at CERN, there are some discussions which are ongoing since 10 years or more. They are always the same when you are in this discussion for the data preservation and also for the open access, the data, at least not the raw data, but at least the N tuples.
But all good points. Something to put into mapping this out further. Something where we know about requirements was the charge which we received from the steering committee. Of course, what we would like to do with the software, simulations of physics processes and detector response. Important is a quantitative assessment of measurement capabilities and their impact on physics. and it should be done in a way that is accessible, consistent, and reproducible. So everything which is written up in red is a very clear requirement on the software, and I will talk about this a little bit more in detail. So let's come to all the aspects of software. Let's start beginning with simulation, Monte Carlo event generators. From the chart, we need Monte Carlo event generators for all physics processes that make up the EIC science case. What does this further imply? We require an organization with the theory community in nuclear physics and HEP. I list HEP because this is where most of the Monte Carlo event generators are being developed. We need a merging of QED and QCD effects in these generators. This is what often is referred to as putting radiative effects in. And the CPU usage will be dominated by creating Monte Carlo. Of course, another aspect of that is detector simulation, but we aim for precision studies at the EIC, so we also would like to have Monte Carlo with next to leading order. So this will also have an impact on our resources. And what this then further on implies that this requires an organization, how to handle the Monte Carlo, how to keep track of Monte Carlo data, and also how to validate the Monte Carlo. If you have any other requirements in which you see related to Monte Carlo, immediately jump in the discussion or send us later an email, and we would like to fill this in our requirement document. Detector simulations. Detector simulations, it's of course, JON4 is the tool. There will be nothing else on the timescale of the EIC other than JON4, but we also, of course, want to have fast simulations. We currently use EIC SMEAR for fast simulation. EIC SMEAR does the job, but there's the question, do we want to have fast JON4 simulations? So discussions which has started is, do we need them at all? Should this be just up for detectors, or do we want to really develop a common system? And do we want to use existing technologies which are already in JON4? When we were at the technical forum with the JON4 collaboration, their strong suggestion was to have one JON simulation of the detector and then be able to tune this up to a fully detailed simulation, or tune this up to really speed, where then a lot of the things are just done with parametrizations. And of course, mix things that you, for instance, say, I would really, my detector, I really would like to simulate this in all full details, but for the rest, I just would like to have some parametrizations. So there's some ongoing discussion going on. When we discussed this also the last time, we were thinking about other existing tools, like for instance this Delphis. So this is something to discuss also again with the JON4 collaboration. Reconstruction. The only requirement which we came up is right now reconstruction should be flexible. We are still discussing detector concepts. So it's not so much about optimization and tuning, it's really about having a reconstruction which works with various detector concepts, and we still can move detectors around. But other requirements which are in particular when things are flexible, we need and get to a well-defined data model, event data model, so that we know what, for instance, is meant by a hit in a certain detector type. And also it was mentioned that it's good from the beginning to plan things in a thread-safe way, and I have an extra slide on concurrency. Benchmark and validation. So this is again from this chart from the steering committee, quantitative assessment of measurement capabilities and their physics impact. So we need benchmark processes, and we need Monte Carlo for those. We need to have validation tools, and we need to have a benchmark workflow. And the question is, if this validation and this benchmark workflow, if that should be already an intrinsic part of the simulation tool and of the development. Something which came up is, of course, to do unit tests. But would this be, for instance, also a test that we say, okay, we have a couple of validated analysis results, and we would like to be always able to reproduce them. So this is something which is ongoing discussion. Yeah, I can always.
Of course, extremely important. But how do you do this in a situation like now, where you develop everything new and you kind of completely are not sure you have bugs?
So Dimitri's fast reaction tells me that he wants to reply to this question.
Yeah.
Actually, tests have many layers of what you mean testing. So, for example, unit testing means testing very small units of your software, which you can do always, even right now. Our software consists of parts which can be unit testing. So, like looking for just plots, it relates to testing called smoke testing. Actually, we just show that all your software works, and it not absolutely kind of shows that everything is correct. And there are many different layers of tests. So there's actually a science behind it, right? With a lot of studies, with also plots and whatever. So the integration tests, compatibility tests, whatever. So and that is and like all industry and everybody is using it, except maybe for part of our field. And actually, in our field, they now are using I use two. And if you look at the experience, for example, CERN experience of the places where they are used, where all this knowledge is used, the software usually is much better and reliable for when they're used. Okay. So it's a kind of complex question. We can do it every time, right now.
You answered a question, but not exactly the one which I asked. So I agree with you that I can run compiler, that my software compiles overnight and whatever kind of all of this, all agreed. But what I was more worried, so for example, I put in a new detector. And the assumptions which I put in could be not correct. How I digitize and things like this, and then we kind of obtain results which are not correct because what I model is not correct. And that is where I was kind of wondering, it's easier, for example, to do this if I have already years of experience. I could compare things to data, and I know my Monte Carlo describes my calorimeter test mean data. Even that is not trivial. Now I change my compiler, and suddenly something changes.
Yeah.
And how do we think of, because it is important if I take decisions on certain things, how do I validate what has been integrated into the Monte Carlo that the model is correct?
Yeah, well, I'm not necessarily.
Not the physics model, you know what
I
mean?
Yeah, I know what you mean, but let me. I perhaps don't know if the model is correct, but at least I would like to find that between what was the previous version, which everyone used, and the new version, that I have some differences.
True.
And this workflow here, where I said, okay, I have, for instance, some benchmark analysis and this benchmark analysis could be some physics output, or it could be some resolutions in detectors. And when this suddenly changes, then I need to understand where this change is coming from. And I don't necessarily not know if the previous or the current one is correct, but at least I know that I somehow have to study that to understand that difference.
But I'm one level below this. I'm wondering whether we have an idea, whether we can validate that at least what is put in is to 90% sensible in modeling such a detector.
Ultimately, it's test beam, as you said, right?
Yeah,
so
but
maybe
if I
it's an
don't have
explicit
test beam,
requirement.
what do I do then if I don't have test beam?
You don't really connect it to reality until you do have test
Oh, but for example, I don't have test bin for all my prototypes, but I will take a decision that a whole silicon tracker gives me a much better resolution than a TPC, to say two extremes.
Can I add, actually?
How do I avoid that something is maybe modeled too optimistic, too buggy? So this type of checks are also important.
Two cents to actually Marcus and to your question. So let's clearly split your question to two parts. First part, what to do if software not right, and the second part, what if physics or our physics understanding is not right. So when you talk about compiler, this part is software not right. And this should be handled by the...
Absolutely.
The right part, the physics not right. That's actually a very interesting question. If you look at articles, so because people start using this continuous integration, whatever stuff, and they kind of came to what should be, if there's a DevOps in software, which answers exactly this question. There is a term called DevOps, right? Can we implement something in physics? And actually they try to answer the same. There are articles how people actually try to implement it worldwide, like for example for CERN and for German experiments. But it's something we can try to, so it's kind of new. So we can try to answer this myself. Yeah. But we have to split it, either the software or physics.
That's why I'm saying this is all extremely important, but there's a level below this, or before us.
And to that level, what only helps us there is intuition. I think what really helps is to develop, let's say, a set of standard plots which we release with let's say a software release, and then you can look there and say, no, this resolution cannot be correct, and this is then based on intuition, because you say, I've never seen an experiment which had such a good performance, or no, the performance cannot be that bad, this is impossible, and then one can look into these details and can say, okay, perhaps the assumptions which were put in are just really too optimistic, and then the other point is, and this comes what we discussed this morning, having various tools to check this and say, hey, in one tool we get a significantly better resolution or whatever other performance than that. But great discussion. So I go to the next one. Another requirement from the charge is accessible to the EIC user group. To what extent do we interpret this? Well, one thing is to have a repository up so that you can get the code, but it's not only the repository, it's also the distribution of the software, meaning that you have, for instance, what we are currently thinking of is containers and CVMFS. And Wouter pointed out that this is also related already to the next point of user-centered design, because often a complaint by users is it's so difficult to get the software installed. This is where your distribution and your packaging helps. The other point is how easy is the software to use. When we had this Future Trends in Nuclear Physics Computing workshop, what was reported there is that as the complexity and size of the experiments grew, also the complexity of the analysis environment grew, which means that the time you have to spend with that grew. And there were numbers not only from LHC but also from NP that half of the time would be dealing with computing questions, and this seems to be rather large, and so the outcome to that is to understand from the beginning what are the user requirements and make all decisions based on what are the user requirements. And that is really something which is typically not done, because often the computing at an experiment or the software at an experiment is written around what are the computing resources which are available, and then put together by a group of experts, often really disconnected with the experiment. But this was 2016, and this is of course something which is acknowledged in the community. So there are others who do service for analysis groups really help with the software, and also the way the infrastructure and the framework is supported. For instance, something which came up with analysis, trains, etc., is really to keep that number down. And I think this is a discussion which we should have in detail, is how can we really make the analysis easy, by at the same time not hiding any kind of complexity. Consistency, that was part of the requirement. The way we interpret that, consistent to the EICUG, is so simulation tools which should be used on all detector concepts, and geometry exchange. Reproducibility. So the results are being reproducible to the EICUG. So we need to have, of course, documentation so that anyone can reproduce the results, and also for the simulation validation tools and the related workflow available, so that anyone can say, I don't believe this, I would like to do this myself. Find documentation how to do that. What we just discussed with benchmarking, with validation tools, also with unit tests, this is important to have reproducible results. We also discussed about self-descriptive data and self-descriptive analysis. So I have a data file to know what do the field mean, what is in that data, meaning, for instance, I have a Monte Carlo file which tells exactly, okay, this has been created in this and that way. And for self-descriptive analysis, this is, for instance, what we are putting forward with distributor notebooks, that really the documentation is coming with the code. And of course, you can also do this in other ways, like in root macros, where you describe really in detail what is actually happening there, and link this also to code, something that, for instance, Dimitri has also shown, to have then directly in the notebook the links to the underlying code. Part of the discussion was then also, if we have data and the framework changes over time, particularly in a stage like that, how do we ensure that the data and its records are compatible after changes? So it would be good if we now, at the end of the RELO reports, have some results, that the results which we have in 2 years, we can still reproduce them and can still read the data files. And ultimately, that brings us to the requirement that something like data preservation, which is such a difficult task, in particular when you do it at the end of an experiment, to build this in from the beginning in the framework. So so this was the discussions which we had to reproducibility. Interrupt me if you have any comments. Otherwise, I go to the next, concurrency. I think for the EIC, where we for sure will use HPC resources, also local resources are becoming more and more multi-threaded. So we should really design this with concurrency in mind from the very beginning. Last but not least, modularity. So is also something from a report which we had for future trends in nuclear physics computing. We said that we need to think about structures that are robust against likely changing in computing environment in both hardware and software. In the EIC will be something like a decade away from us. And so that means modularity is important. And so we need to think about how to modularize the underlying code and database structure, so that we can deal with changes in, for instance, the hardware, without having to do an entire overhaul of the structure. And this is related to what, for instance, we've shown in the morning, and also what Dimitri showed in his presentation, and also what Chris has shown, in the sense that that you keep your code very, very modular. So what this implies is, so we discussed it's important to define interfaces, and the requirement of many of us was to keep them simple, but then a discussion came up, or keep them not simple. So there's of course the advantage when working within one language or one strict analysis environment that one can share complex objects between various steps of the software. But of course this is not possible when then going, for instance, to analysis environment which is built up by various languages. And so something which came out of this discussion is that you really need to have a focused meeting on that and understand why various experiments who started with rather complex interfaces over the time started to simplify their interfaces. And the same goes to flat files. For instance, many LHC experiments use now flat files, and many of us think that is also a good idea for the EIC, but then when we discussed it the last time, there was also the question, okay, can we really clarify why this is a good idea and why we want to do that? So that is something where we would like to have a focused meeting on that. Modular, of course, means, and this is done, this is good practice, is to have all the steps of detector effects, digitization, event construction, have this modular. Of course, this requires geometry exchange between simulation, digitization, and event reconstruction. This is of course good practice, and really think about support for heterogeneous hardware. This is also something which was coming up in our discussion. So let me wrap this up. We started to think about requirements for Greenfield software. This is where we are regarding thinking about aspects of it, and so our next step is to complete this discussion and write this up, share this with a wider community, so that we can finish step number 1, define requirements and write them down. You have any comments, suggestions?
I mean, with the file formats, I mean, basically, if I go back to when Rick was designed, if we had decided on the file formats, we would have said, oh yeah, Paul, we need RZ files. That's what we need. Yeah, that would have been a really bad idea. So I think I mean, you can look into advantages, disadvantages now, but saying, okay, this is what we're going to do, it's way too early. To basically nail the, you know, again, investigating, yes, but saying, okay, this is what we're going to do in 10 years, that's a big mistake.
Yes, I absolutely agree with you, and that is mentioned here, likely changing in computing environment, both hardware and software. In 10 years, we likely have a very advanced and very clever file format, which we are right now not even thinking about. But this does not mean that we right now at a certain moment should not discuss about how the interfaces should look like, so that, let's say, we change the file format, we can easily do that, and our analysis environment, for instance, is not depending on a certain file format. And of course, we think we would never design something which would only work with, let's say, POR or a certain type of root files. It's the discussion is here really more about how the interfaces should look like and how simple or complex they are. But yeah, good point. Further comments, questions, suggestions, criticisms, complaints?
So how, so all you say, some of the things are already done and you need to think about that you continue doing them. But of course, how, if you now start to define something like this Greenfield, and then there comes a collaboration along and decides something else, how transferable is the effort you do right now to something in a year from now? And is it at this moment the right time to put effort in?
This is, like many of your questions, a very good question.
Thank you. And it's not meant as a criticism.
No, I don't see it. I don't see it as a criticism. So I think these steps 1 or 2 will be benefit of anyone who comes later, because this is more or less an informative document. Any collaboration can come and can say, okay, there has been a working group.
Yeah.
They thought about what is important. Like in general, the yellow reports are thinking about what is important for detectors, what are requirements, and also then look around what is done and get some.
So you don't do yet real choices. It's more on a higher level, defining things and providing input to the collaborations that they have an easier start to go from there to something concrete.
Yes.
Okay.
I mean, think a little bit about it. What Andrea, you and I already started regarding Monte Carlo is to say this is available on Monte Carlo and this is Monte Carlo, which is still needed. For anyone starting on this topic, having this written up in a concise document is, I would claim, a benefit. Now, the other questions here, I think, strongly depend on the questions which we currently don't know, how the EIC project will be organized and what the timescales of that are.
Indeed.
But therefore, the idea is not to now stop all of our work and start coding something. The idea is really, for someone who is very skeptical on that, I would present it in a way is that what we do right now for the Yellow Report study is already coming up with some kind of prototype for this framework, or two prototypes of this framework, and or perhaps at the end it will be 3 or 4 prototypes of this framework. But I think it does not hurt to actually write up what we do, what our ideas and what our designs are, write this up in a document and put this in a big picture and say what we are doing is, for instance, very similar what these and these experiments are doing. And these are the steps. Andrea and then Dimitri, you wanted to say something?
No, I was wishing to say what you were saying. If I can add, I think that opening to the wider community is an important part. If we can benefit from work which is already ongoing, that would be
Then Dimitri?
Yeah, I wanted actually to, I see the situation a little bit different, and maybe I have a different wording for it, but my conclusion would be the same as yours, that this thing is relevant. So one of the brilliant phrase I heard somewhere, that you cannot just write software. It's not possible. What you can do is you can grow software from something, right? And certainly, if we see how we certainly say that, okay, like in 10 years, whatever we do now will not be significant, right? There will be something else. But at the same time, it's not possible just at one at one moment say that, okay, now we obsolete everything that was before, and now we sit, and 3 years we write software, and having the requirement, in 3 years we'll have the software. It will never work like this. It's not possible. But what is possible right now is, and I'm pretty much sure that whatever we finish, the software that we have right now. I mean, that like all software will have some impact. Everything will have an impact how it looks like in the end. And right now, even for the software right now, it's very important to know where to shift the things, where you go. So for example, even with this G4E and stuff, right? So we are now developing it pretty rapidly, and we have to make some decisions. And when we are making these decisions, I personally would like to have such document which actually have some points decided, and I can just use this collaborative decisions and know that I am going in the right direction.
Alexander.
So let me ask a provocative question.
Oh,
As you,
something
so
unusual.
from what I hear, and assuming that the frameworks which we are going to use for this year are limited in time, so do I understand correctly that on a time scale of a couple of years from this particular Greenfield effort, we are expecting only community documents and no codes? This is how it sounds?
I don't know. I
Yes,
think,
but let me clarify. So as long as you have not decided on the requirements and you are going to propose these requirements to the future collaborations, so you cannot start coding in some sense, right? So do I get
You even
right?
cannot start coding without some very simple decisions like, okay, let C++ be our standard.
Yeah, but I asked my
Okay.
question. So
Yeah, I'm
so,
sorry, I just agree with your question.
So does it sound like nothing but the documents requirements comes out of this effort before we have the collaborations?
It
well,
depends when we have the collaboration. If it would be in
I
1
don't see
year,
any,
I think.
I don't see any dependency.
well, let me present things a little bit different perspective. I think this question number one is already part of coding. So to some extent, you think a little bit already what you would like to do and in which direction you would like to go. So when you and I started the EIC Software Consortium, we learned very fast, and this is no surprise to anyone who is involved in software discussions, that software discussions can go very emotional and can go very, very heated fast. And a good way to structure software discussions is, instead of comparing tools, is actually to define requirements, what is really needed, and then discuss how does tool A, how does tool B, how does tool C map these requirements. And that typically gives very fast an answer about how suitable tools A, B, C are for this particular task. And therefore, I personally see this as a very important point. So then I would say that the implementation, even so this is fun and even so this is interesting, is a question about available resources. So the yellow reports are of course a priority. In addition to both labs, Brookhaven and Jefferson Lab, will share major responsibility for the EIC project, which will mean that at least scientists at these labs will be also to some extent be busy with these responsibilities. So the question is, what are the resources available for implementation? And if these resources are available, then why not just doing them? Tore?
One reason we came to this Greenfield plan was because we did have two efforts going on that the community as a community did not agree on, with a community around each of them. And we could see that neither one of them did we want to get stuck in the ruts of to carry us forward with a lot of further development work on that specific thing. And the Greenfield approach is kind of a reset, an acknowledgement that whatever we do in the future, we should be trying to do together as a community. And it's on the side of leaving a greenfield for the collaborations that are coming in the future, and not trying to drive forward some preconceived notion of how we should be doing the offline software. So in terms of what the greenfield work would actually be, I don't see why it couldn't be prototyping something. You know, if you have available effort and a few people interested in going and trying Gaudi, which has been successful in a number of experiments and is all multi-threaded and is also now being used in a streaming DAC environment, then why not? That would be effort that informs the decisions later on in whatever is done in the collaborations. If we were going to have collaborations in 3 months, there wouldn't be any point to it. If it's going to be 18 months, then we have 18 months to inform ourselves.
In my language, I would call this a position paper, kind of, discussing what you really want, what you need, what is available on the market, maybe already do some pre-selections.
Prototyping, not pre-selection.
Huh?
Prototyping.
Yeah, but also saying that, for example, there could be a framework you just will, or something which is completely incompatible with a streaming data acquisition, because you would like to use, so that's what I mean with select.
Yeah.
You know, that you have a certain requirement which you can say, you make a matrix, this and this exists, and da 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 da, and then also prototyping potentially, and you say, okay, this 5 too old, or some whatever the you kind of, and that of course is indeed valuable information for anybody who comes afterwards. Yes.
And something which we think about including in the yellow report. Salvatore, you wanted to.
Yeah, probably you already answered partially what I was about to ask, because item 3 and 4, to me, it kind of naturally requires the formation of a collaboration. But now I understand that this is actually an exercise that you want to do prior, or because nobody knows the timelines right now. But
yeah, but we do know that once we have collaborations, you know, we're going to be in the collaborations, right? It's not like we're doing something and passing things off to.
And implementing are something that requires this.
Yeah, but it's about
right?
informing ourselves and preparing, anticipating.
So, wait, Dimitri is.
Yes, I just wanted to put it this way, actually, kind of agreeing both with provocativeness of Sasha's question and actually to Tori's answer. The risk when you just put your requirements and work a lot of time on it is that when somebody, if no coding is happened, that then when somebody comes to implement thing, you just throw out all those requirements and do something else. And to prevent this, there should be some balance. And actually, this prototyping and doing some coding, which Tori mentioned, is the solution. Is this? It brings this balance.
This is a very good point.
Yes. So basically, answering to Sasha, yes, we should actually. As I see it, we should start doing some coding right now. But doing this coding, we should follow what Tori actually said about prototyping and doing stuff.
So I think EICUG is
a practical thing, because you ask what is missing. I think the one thing which you have not discussed is indeed how easy your framework is with handshaking with your data acquisition system. And I'm bringing this up because, as we discussed in this DAC discussion, which we had the floor up, we were saying that we need a certain information available very quickly. So like the 10% of the data or the percentage we can discuss, to give feedback to the machine, to see whether our detectors are fine and so on. And I think that is a requirement which maybe should be thought of. How easy the handshake is with streaming data acquisition, for example, as a requirement.
Yeah.
It has to be designed.
Yeah, but
with that
for
in
example,
mind, I think that we cannot design it out of the blue. We have to see what is happening.
Understood, but I'm just saying that it is a requirement which was not listed.
Yeah, no,
it's a nice
no,
list
right.
of Marcus, which Marcus had,
You're right.
Because you were asking, was it
Yeah.
if something,
No, I think this is something which should be included.
Yes.
We had a lot of some of the points which are not so obvious, but we had some of the trivial points in there,
Yes.
and I think the DAC and requirement for at least part of a real-time or near real-time analysis is a very, very good extra
I mean,
point.
the easiest way to do that is basically not having an online and an offline group separately.
Yes.
That's. I mean, in Phoenix, we never did that, and it,
Yeah.
worked nicely.
true, but it's something which is important.
Yeah. So but
Yeah, this is anyway a trend which you have this blurring of online and offline things, right?
If you go to, can you go to your last slide, the one with the requirements?
You mean this one?
Yeah, this one, yeah. So I was again, given my ignorance, I'm not too familiar with how much has been done in terms of EIC software. But I was thinking if you can write some software interface to kind of do analysis on all of our old data, then you essentially will get all of these requirements, because you know that if your interface will work with, let's say, Hermes data or some old Fermilab data, then it can work with anything that comes in the future, and it's something you can start writing because you have the data that you can kind of have as a guideline for how people are going to use it and interface. So it might be.
Yeah, but you not necessarily catch everything. So, for instance,
Well, yeah, it's not no software is going to be universal, but I just think in terms of starting to develop some kind of software, that might be something worth considering, is how well our design can work with older data.
Yeah. No, that is definitely an aspect, and I think this is a very, very valid point which you mentioned. But it's also a little bit beyond that. So someone who spearheads Monte Carlo productions on HPC resources is Stefan Höche, who's currently at Fermilab. And when he started to run his Monte Carlo for the first time, it was extremely inefficient, and he learned a lot of things how to improve his software where he at the beginning had easily factors of 100 or 1000 just in speed improvement, just because it was a completely new architecture, and it is not impossible that there will be a completely new architecture around in 10 years from now. So this is something to put in. And these items here related to discussion or not, this comes a little bit to the point about what languages you use. So currently in our community, C++ is the standard for data analysis tools. But this is not necessarily the standard in the data science community. And also in our community, there was David Blight, who's a postdoc at Argonne, and then he left to industry, who did some very interesting prototyping work by using Google protocol buffers as serialization layer, and then having all the aspects of a simulation framework implemented in different languages. So he had some things written in Python, he had some things written in Go, and he had some things written in C++. And there's of course the question, is this really something which is a requirement for us, that we would allow that part of our software would be written in another language than C++, like for instance Rust or Go or Java. And immediately when you bring this up, you get very strong opinions on that, but there of course are arguments back and forth. But if you
But another motivation that everybody agrees on is like moving data in and out of GPUs.
Yeah,
You know, you want fast and efficient, and that argues for simple data structure.
Yes. But wait, let me finish. And that of course then drives, for instance, if you would agree that you have only C++, then the way how your interfaces look out will be completely different than you say you actually would like to allow, let's say, C++ and Go and
Why
Python.
would you allow that? Because I mean, look, in our world, people come and go. Yeah, so you don't really have somebody hired and then they stick with your company for for the lifetime of the project. So now you basically
that is not true. Most of our people are 30+ years here.
Yeah, right, but not the ones who write the code. Not the ones who write the code.
I write the code.
And this basically means then you have to have multiple experts there. Expert in Go, and if the kind of you need, rather than having one language, you say, okay, everybody learn that one. And
yeah, no, absolutely good point. I'm not disagreeing with you, but then the question is, even so, a lot of us now learn C++. Is C++ really the right language for?
I mean, Java was a giant failure when they tried
for that.
So,
But I didn't want to argue now what language. I just wanted to illustrate this point about interfaces. Alexander.
So do I get it right that story with Google Protocol Buffer implementation is an example of prototyping which you have in mind?
No, this is what I said. I was just referring to an existing example of prototyping, which I think was highly interesting how it worked. I'm not saying that this is how the EIC software should look like.
Do you realize that basically that effort was wasted, so to say?
No, I don't think that this effort
to a large extent.
No,
and it costed months, FTEs. I mean, for 2 people. So is it the prototyping which we have in mind?
No. I think this comes now to the category of putting things completely out of context. Everything what I said in the last 5 minutes was as an answer to the question below, to illustrate this discussion what we have here about defining interfaces. I was not making any statement towards that. To make now a statement is that I claim that C++ is the wrong language for analysis at the electron-ion collider, because the language is too abstract for most of the users, and having a simpler language for the analysis.
What do you mean by analysis?
I mean high level.
You mean the reconstruction?
I mean the analysis, like for instance making a DBCS analysis or making a TMD analysis. I'm not meaning the underlying code where you really do your calibrations and your reconstruction.
At some point we risk going like this, in the sense that we need the expertise. If we keep the undergoing analysis in C++ and we make easier interfaces that students will use for the final analysis.
Yeah. But C++, when you look for data science, it plays absolutely. Yeah, it absolutely has no relevance. Mm-hmm. And even so, it's a great and powerful language. It is just right now ready as a language, and we were already using.
Is this discussion not a bit esoteric?
Yes,
I'm seeing. Let's do something, girl. So can we kind of come back to something more less esoteric?
Yeah. And I think we have a very concrete plan which we discussed. Is it about C++ or something else?
Something else.
Okay.
So correct me if I'm wrong, but starting to write something now, even interface, must depend on what data are supposed to come from DAC. So I think we should get in touch with them and get some notion of what to expect.
You will get a binary file. Not an unpacker.
I not always agree with Chris, but here I absolutely, I absolutely agree with him.
Not going to listen to
We
an
can get-
online person telling them how it should look like.
We may arrive in getting qubits. So
Going even more as a term.
yes.
Yeah.
Because if discussions become too esoteric, it means the meeting is over.
But,
That is what I wanted to
No, but
suggest.
Jaroslav has a big point. I mean, we are in S Phoenix, we're having the problem. I mean, you have streaming DAC and triggered, but in the end, the analysis, you want to give events up there. So how basically make this transition at what point you say, okay, from here on, I'm dealing with events, and under it, it's streaming, and above it for the analysis, there's events. So that's something to think about.
That was also.
In the other meeting, when is an event? Yes, I remember.
But that
was
goes into this.
what
Yes,
we
I
were
know.
This is
discussing.
something which we should add, yeah.
That was what we were discussing lunch break or whatever, where we structure the reconstruction will run on streaming events, or reconstruction will on streaming, or it will run on events. So we will reconstruct with the time road the event that is coming, or we will reconstruct the event which is already put as an event with a certain time, and so that we can take this event and do the reconstruction. That is something that we will have to discuss at some point. What we will have? We will have 4-dimensional.
That depends on what
It's
we are
all-
deciding our data acquisition system is. I don't think we have decided this yet. There are ideas about this. And Dan is doing some things, but they will not stream out everything. At least as far as I know, none of the experiments can. I have a daily experience on the fair, a data acquisition system, which I don't want to report on. And so I think we haven't decided on this, and that is a decision, for example. That's why I said it might depend also how your software looks like.
That will change the software.
And this is another example for likely changes in the computing environment, both hardware and software, that this has, and I think we should illustrate this point a little bit more, what we mean by that.
So Torre, is any one of the LHC experiment streaming all information? As far as I know, they do data reduction, all of them, is that correct?
Data reduction on the fly.
LHCb is streaming.
No, whether they stream really all the information or they do a data reduction before they write. And all of them do data reduction, as far as I know.
But LHCb would like to remove that and go to.
But right now they are not doing.
Right now they're not doing.
No.
That's what I was.
But this is in the planning, yeah.
I hope it works.
I just want to reconstruct everything right only, let's say, 80% of the data.
Are there any more comments? We're restricted on the C++ topic. So
you can continue.
Otherwise, I would give the microphone, hanging up here, back to Torre as our host who put this all together.
Well, yes, then I think that wraps us up. And thank you all for coming, and thanks to those remote for participating remotely. We're going to have a dinner. If you haven't signed up for the doodle, we have 8 people signed up. We welcome more. We reserved for 10. The reservation times were oddly quantized at 6:45 and 7:15, so we actually made a 7:15 reservation. But I suggest we stick to our plan, get there at 7 o'clock. We can always have a beer. They have a good selection there. And then tomorrow we're into the R&D meeting. So thank you very much, everybody.
That's fine.
Yeah,
Saves me a lot of
I know a lot of work
headaches.
I gotta do there.